everyone. I'm going to divide this Webex lesson into two parts. I have the longer version already on YouTube, but we're pretty much going to go over the same stuff. So let's go ahead and get started. So we're going to talk about polygons today. Now polygons are simply a closed figure on a plane. It's two-dimensional. And it's formed by three or more joined segments called sides. So we're going to get some terminology out of the way first. So here I have a polygon. It has 1, 2, 3, 4, 5 sides, and we actually call that a pentagon right here. Let me see if my pen's going to work for me today. There we go. Okay, so there's a pentagon. These are going to be your vertices right here, and we label them by points. And remember, points are labeled by capital letters. Our side lengths can be named as segments, so I could call this AE, and we have a little segment above that, or AB, so on. So inside here we have interior angles. We'll have exterior angles. We'll talk about those in a few seconds or a few minutes. So we have consecutive angles, consecutive sides, and our sides are labeled A, B, C, D, and E. And I could call this pentagon or polygon A, B, C, D, E. The way we label it is actually very important. They have to be consecutive vertices when we label these. So we just don't jump around. Okay? So that's pretty much a polygon. And again, I have the longer video on YouTube. We're going to try and keep this one as short as possible. First thing we're going to do is we're going to have the sum of the interior angles. Now, early on in the year, we learned that the sum of the interior angles of a triangle add up to 180 degrees. This angle plus this angle plus this angle is equal to 180 degrees. And I have a proof on that. It's a pretty straightforward proof. Given that, we can take all convex polygons. There's things called concave, but we're not going to talk about those on these lessons. So we have the ability to draw diagonals in all the polygons we're going to deal with. And when we create a diagonal, we create two triangles. Here's one triangle and here's two triangles. Well, the sum of the interior angles of this is 180. The sum of this is 180. We just add the two sums to get the sum of these four angles. And that would be 360 degrees. We have four sides, but what we did is multiply 2 times 180 to get 360 degrees right here. Okay, four sides. We could create two triangles. If we have a pentagon, 5 sides, we can create from one vertices 3 triangles. 1, 2, 3. So we simply do 3 times 180 and come up with 540 degrees. 6, we're going to multiply 180 by 4 because we can create 4 separate triangles. So you might see the pattern here. If we have 8 sides, an octagon, we're going to multiply by 6 and we're going to get a much bigger number, whatever that is. An octagon is going to be 180 degrees. No, 1080. My mental math is a little slow right now. I should grab my calculator. Okay? So 1080 and so on. So again, it's how many triangles can you create from one vertices going to the others, and we can create quite a few here. 1, 2, 3, 4, 5, 6, 7. So this must be 9 sides. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. Yep. Okay? So moving on. So we have a formula here. It's basically the number of sides less 2 times 180. This is the number of triangles we can form right here. So if you have 11 sides, you're going to do 9 times 180, so on. Again, we have 1, 2, 3, 4, 5 sides, so it's going to be 3 times 180 is equal to 540 degrees. Okay, moving on. And again, always pause these, write notes, work the examples, unpause, and continue on. So first we're going to count sides, and I always double count, so I have to be careful. So what I do is I just create tick marks. 1, 2, 3, 4, 5, 6. 6 sides, n minus 2 times 180, and pretty soon you wouldn't have to write this formula. If I have 6 sides, this is going to be 4 times 180, and that's nothing more than 720 degrees. Use your calculator on these. 6. What we have is an octagon. We're going to subtract 2. This is equal to 8 sides. So we're going to do 6 times 180, and we just did this on the previous slide. That's 1080 degrees. Moving on. So working backwards, what we're going to do is we're going to give you the sum of the interior angles, and you're going to work backwards to classify it by its number of sides. So remember, our formula is n minus 2, that's an n, times 180 is equal to the sum, which is 900. So step number 1 is you're simply going to divide by 180. So 900 over 180, and you grab your handy dandy calculator for this. So 900 over 180 is going to be 5. Step number 2, you're going to add plus 2. So 5 plus 2 is equal to 7. We have 7 sides. Same thing here. Step number 1, divide by 180. So 1440 divided by 180 is going to equal to 8. And then step number 2, add the 2 sides. So we have 10 sides. Okie doke. Moving on. Again, pause these, go back and rework them. So we're going to start throwing algebra at you. Instead of doing proofs, we're going to do algebra. So I have 1, 2, 3, 4 sides. That's a quadrilateral. One of the ones that I want you to have memorized is the sum of the interior angles of a quadrilateral is equal to 360 degrees. I could form 2 triangles, 2 times 180. So we're simply going to add these up. X plus 91 plus 120, just going around, is equal to 360 degrees. I'm going to grab my calculator, subtract 189, I'm going to subtract 120, I'm going to subtract 91, and I get x is equal to 60 degrees. All right? So, moving on. Number 7, I have 1, 2, 3, 4, 5 sides. So n minus 2 times 180 is 3 times 180, which is 540 degrees. I add all these up and equal it to 540. Well, the algebra is not too bad. I'll go ahead and write it out. I'm going to have x plus, I'm going to go around this way, 105 plus 118 plus 75 plus 130 is equal to 540. Grab that handy dandy calculator, subtract this, subtract that, subtract from 540. I'm going to get x is equal to 112 degrees. Moving on. Okay, Polygon exterior angle theorem. Now this is actually a pretty big deal, and this is one reason why you're getting, if you ever played those old computer games from the 90s or 80s, and the faces are all kind of angular and the graphics are real choppy, what's happened is back in the day they would use hexagons for a lot of their computer graphics, 6 sides. Then the computer graphics got better with better graphics cards, and they got 100 sides, 200 sides, and eventually if you got a polygon with thousands of sides to it, it's going to look pretty much like a circle. Very smooth, very curvy. Well, a circle is 360 degrees around. So what you're doing is, the more exterior angles, and this is what an exterior angle looks like, we're just extending these lines out. We're just extending them out. If we were to add all these up and go all the way around the circle, that's going to be 360 degrees. So my exterior angles, this one plus this one plus this one plus this one plus this one, is going to equal to 360 degrees regardless of the number of sides. So just think about it. You're just going all the way around. You're going to start right back where you started, go all the way around, and you're going to end up at 360 degrees. So when we do something like this, and we're not going to do a whole lot of these, this is actually doesn't have a whole lot of purposes for our future math classes, unless we're dealing with regular polygons, and your computer science people are going to be really familiar with this. We're just going to simply add this plus this plus this plus this is equal to 360 degrees. So I have 3x plus x plus 86 plus 90 is equal to 360. That's 4 x's. That's going to be 176. Someone can check that with a calculator for me real quick. Is equal to 360 degrees. Subtract, that's going to be 418. All right. So 4x is equal to 8. What did I say? 18.4? Okay. All right. Yuck. That's going to go into it 40 times plus 6 more times. 4 times 6 is 24. So that's going to, and again, use your calculator, folks. 46 degrees. So this is 46 degrees. This is 3 times. That's 120 plus 18. So that's 138 degrees. Alrighty. So, moving on. This is where we're going to spend the bulk of our time, and regular polygons are massively important in future math. You're going to learn about this if you go on to calculus and courses like that. So a regular polygon is simply a polygon that's equal sides and equal angles. So all the sides are going to be equal, and all the angles are going to be equal. We already talked about equilateral triangles. These are all 60 degrees, and these sides are all the same. Now, a triangle adds up to 180 degrees. We have 3 sides, and we know that the angles are all 60 degrees. So here we have 1, 2, 3, 4, 5, 6, 7, 8. An octagon, okay, has 8 sides, and all these angles are going to be equal. We already found the sum of the interior angles of an octagon to be 1,080 degrees. Okay. What are the individual angles? Since they're all equal, all these angles are equal, you just simply take the number of sides and divide it into 180 degrees. So we're going to divide by 8, and I'm actually going to grab my calculator on this one. It says 135 degrees. I probably should have had that memorized. Okay, it's been a while since I've done polygons. So 135 degrees for every one of these angles. The exterior angle is going to be the supplement of that, so it's going to be 180 minus 135, which is equal to 45 degrees. And if I were to take 360 degrees and divide it by 8, I'll get 45. Okay, moving on. So we're going to give you problems like this. So a decagon has 10 sides. You can always look these up because there's no reason to have them memorized. And if I wanted to find the measure of each interior angle and exterior angle for each regular polygon, the interior angle is nothing more than n minus 2 times 180. That gives me the sum, and we're just going to simply divide by the number of sides. So n minus 2, given 10 sides, is going to be 8 times 180, which is equal to, using the calculator, 1,440. And then I need to divide by the number of sides. So I'm going to take that, divide by the number of sides, and I get 144 degrees. The exterior angles is pretty straightforward. Exterior is nothing more than 360 divided by the number of sides, which is equal to 36, which makes sense because this is going to be the supplement. Okay? So exterior is real easy to find. I'll go ahead and do that. I'm going to do 360 divided by 16, and that's going to give me 22.5. Well, I know the exterior angle of 22.5 is the supplement of the interior, so I could subtract 180, do 180 minus 22.5, and I'll get 157.5. Okay? That's my individual interior angle. Or I could go back here and do n minus 2 times 180. So 14 times 180 is equal to 2520 is what my calculator says. Okay? And then I'm going to divide by 10. Well, that's just... divide by 10, divide by 16. Ha! I was wondering why it looked weird. So 157.5 degrees. Okay? Oh, I did 10 by the last one. Alrighty. So that's going to be it. We're going to talk about parallelograms in part 2. So I'm going to go ahead and get this loaded and then do the parallelogram one.